Hey everyone, welcome to MoQuality's first webinar on using bots for advanced exploratory testing on your mobile apps. I'm Vaibhav Gupta. I work with MoQuality on marketing. Today's speakers are Shavik and Pushkar, both co-founders of MoQuality. Shavik, could you please introduce yourself?
Hi everyone, I'm Shavik Roy Chaudhary. I'm the founder and CEO of MoQuality, and I've been developing software testing tools from the last 13 years, and really excited to do this webinar with you guys. Pushkar.
Hi guys, I'm Pushkar. I'm the in-house AI expert, and I basically wrote the AI software with which we are doing mobile app testing. And since this webinar is about robo testing, I'm really excited to talk about how we are building robo testing.
All right. Let's jump into the agenda for today. We're all very excited to talk about exploratory testing. And this webinar is going to be a conversational style webinar where I am going to ask both Shavik and Pushkar some of the questions that you all have sent us. And we'll start off with discussing what really exploratory testing is and what is the real need for it. Today, how manual testers are doing exploratory testing, and how can a robo help in this by automation, right? And what is the advantage of robo when it comes to exploratory testing? And then Shavik is going to talk about how the future would look like when we use robo for this. Also, you have the question and answers available on the chat, so you can always feel free to post any questions and we'll take them one by one. So let's jump in. Shavik, what is exploratory testing from your experience? Please share.
Yeah, so exploratory testing is essentially testing beyond predefined test scenarios or test plans, right? And essentially you are investigating the app just as a user would. And this actually helps us find issues. One of the common issues that test scripts don't cover is imagine a case where you are filling out a form in an app and you rotate the phone's orientation from landscape to portrait, and all the details that you have filled just suddenly disappears, right? This is a very common problem. Another problem is that, while you are in the app and you hit the back button, the developer might not have handled it. So it could lead to the app, just quitting or even crashing, right? So these are some of the common scenarios that typically test cases don't cover, and you find it in exploratory testing.
All right. And why do we need it really today?
Yeah, so essentially, we always want to find more bugs early on before our apps reach customers, right? So you want to find unexpected behavior, you want to increase your test coverage, right? So those are the main two reasons. But other than that, consider standard testing where what you have is your test scenarios. We write it down, but they often are outdated or they often are vague, and testers are not able to follow it, right? Also, if we script tests, then they could be incomplete. Which means that they're not getting us enough coverage. Also, testers should think like real users and use their experience and creativity while testing, right? So that is why we need it. But what does it give us? Well, the obvious one is more coverage. You get more test coverage. Also, you don't need any preparation, which means that you just get the app on your phone and just start exploratory testing. It allows you to find unexpected issues. And also, it is very intellectually stimulating as you're going through the app, just trying to emulate a user.
All right. So from our conversations with customers and people that we've been talking to, how do you see people doing it today?
Yeah, so when people do exploratory testing manually, there are essentially three ways in which they do it. The first way is to do it freestyle, which means ad hoc, just take the app and test it in a very ad hoc way, just like users would. The second one is goal-based, where you have an end goal in mind. And typically goals are, either getting to high coverage or finding all the kinds of, common bugs that are in the app. So you're trying to maximize towards those goals. And the third one is scenario based, where you might have a high level, scenario that a user would use the app in a certain way. And you are just following through the high level scenario to test the app from a user's point of view.
Okay. And what's missing here really today in these approach?
Yeah, so since exploratory testing is mainly done manually, the biggest thing that is missing is documentation. So testers would often take screenshots of every screen that they would traverse, and managers would then go through it to monitor and track how people are testing, right? Also, testing is a time-bounded activity or resource-bound activity. So we often are limited by time, cost, and people, and we are trying to maximize the results in that, right? So all of this is missing, which results to very undefined results. We are unable to explain what was tested in an exploratory fashion. Also, the bugs that we find in exploratory testing, sometimes they are very hard to reproduce. So those are some of the challenges in manual exploratory testing today.
Okay, thanks a lot, Shavik, for sharing these insights. Let's now ask Pushkar, how does a Robo do exploratory testing? How is it useful?
Yeah, so as Shavik said, a lot of time is consumed if you do exploratory testing by hand. So it's an obvious place for using machines to do exploratory testing. Uh, a robo is almost like any machine learning system. It has two parts. In the first part, it does some kind of learning and creates a model, and then uses the model to do some kind of task. So for our robot, for example, we do the robot in two phases. In the phase one, we create a model using some goal-based learning techniques. And then after a model is created, then you can use that model and explore the app while doing testing.
Right. Can you give us some example here? How do you do the
Yeah.
goal-based learning?
So, uh, you know, famous games have been used, by Google for like telling us about how machine learning works. So, for example, here is a demo of Shavik playing the Flappy Bird game, pretty badly, I must say. But this is a goal-based learning technique. So, what Shavik is basically teaching the machine here is how to play the game. The machine itself doesn't understand the rules. So, after a while, the machine sort of tries to emulate Shavik's play method and then creates a lot of data. From this particular data, it then tries to learn a model. After it has learned the model, it itself can try to play the game, right? So in this case, we provided two goals. One goal was to play it like Shavik, and the other goal was to actually increase the score. So if in the middle video, you can see that the bird is actually playing pretty well, and then after a few hours, it does very well and emulates the game perfectly. And then you can sort of use some other techniques where you can take this knowledge that you learned and put it on the other game. In this sense, in this game, these two games are similar because they are 2D physics-based games. So a model that was learned on the first game could be used on the second game.
Okay. I'm sure a lot of people find this very interesting, but how do you apply this to business apps?
Right. So, this all looks great and fun for games, but in business apps, the model looks slightly different. There, the model that we need is how all the screens are connected to each other. So, for example, in this particular app, the goal was to explore as many screens as it can and find all the connected screens together. So here you see that, our robo went through the app and found all screens that were connected to each other. Now, this was the model that was created. Then when you have to do exploratory testing, it just has to sort of either greedily or in some other fashion explore the graph and then find places where there are bugs or not bugs.
Okay, so we've seen how the robo works on games and business apps and what the results could look like, right? But could you now tell us how do you actually train the robo?
Yeah, that's a good question. So, with any machine learning system, the hardest part is training, right? And training becomes easier if you have a lot of data. But in our case, there is not a lot of data going around because every app is different from each other. So obviously, you have to use some kind of unsupervised technique to do this machine learning. So usually in machine learning, there are two ways of doing machine learning, unsupervised and supervised. In unsupervised, you don't have any labels or there are no labels given to you. And supervised, you have some data that was labeled by some user or not. So in training our robot, we actually use both those techniques. So for example, in unsupervised, we try to classify apps that are similar to each other or screens that are similar to each other. And in supervised learning, if we have test cases that the user gives us, we try to infer test flows from that script and actually input it into our robot system.
Okay, let's show the example to our audience how the training works.
Yeah. Weber is clever. He already had some examples laid out for us. So for example, here's a clustering algorithm where the algorithm is able to identify similar screens. So in this case, these are some of the apps that we have been testing for a while. And as you can see, every screen is some kind of login screen. So the clustering algorithm here is working off features from the screens, such as what are the kinds of widgets on the screen, how many text boxes are there, how many buttons are there, and that's how it came up with this final conclusion that these screens are similar to each other. Then we have some data where people have used login screens. So for example, on the first app, we know how the user always presses on the username first. So that's why there's 90% probability that the user is going to interact with the username field. We can infer that as a model and then use it on the second app and say that, okay, there's a pretty good chance that the user will probably enter email address on the second app. In this way, you can actually use clustering and unsupervised learning and then transfer knowledge from one app to the other app. Does that make sense, Vaibhav?
Yeah, it does. So how does it learn from the user-generated tests?
Right. So this is only something to do with clustering. So how do we use supervised learning? So let's say if we have tests where a user actually does login, then he sort of goes from username to password and then clicks on a button. So how do you actually use that data to get into some other app? I think the hard part about this problem is not that there are these test flows, but how do you get this data out of these test flows? People just use apps, but there are you can have code where people actually have login scripts, but it's very hard to use that data into a machine learning system. So you need some kind of recording tool or a test authoring tool where users give you this data and then you are able to extract that data to put it into your machine learning system. So in our case, actually, we have created or developed a test authoring tool. So this is, for example, that our demo of a test authoring tool where the Lyft app is being opened and then the user is sort of going through a flow here. So the Lyft app actually has a very different login flow where it first initializes into a staging environment and then logs in. So we can actually have the user go through this entire process and then input all the information into our system that is required for the Robo to further go in and then do Robo testing.
So this is a simple login kit. Can you tell us what the Robo will do if it's a complicated login?
Right. So usually, what you can learn from multiple simple flows is a common model that works across all apps. So for all the apps that have just a username, password, and login button, you can basically develop a machine learning model that works across all these apps. But if a flow is completely different, then you have to somehow teach that to the robot that for this particular app, the flow is completely different. The way we sort of deal with it is we ask the user to give us that flow and then tell us that, okay, the Robo needs to first bias completely towards using this new flow and then start doing Robo testing. So for example, since we are showing this video, in this example, the Robo is supposed to sort of go through this very complicated login flow and then start doing Robo testing. And we basically tell our robot that, don't even try to use the basic login model that you have. Just use this new model that I taught you for this particular app.
So after all this learning, how is the Robo able to work on the same app and what do the results look like?
So yeah, so once you have learned a model on one app, then you can actually use the same model on all the versions of the app on any phone. And then the results, as far as Robo testing is concerned, is everything that Shavik was talking about, right? So some are freestyle flows, some are user-based scenarios. So for example, here is an example where a user might have set a goal inside the Lyft app, and the Robo is able to sort of use that scenario and then find it out while doing exploratory testing. So in this way, exploratory testing like creates flows just like users will, and sometimes it can. You know what? I will actually just switch and try to show you a live demo of how this works. So for example, this is our dashboard where you can see, various runs have been made. So for example, if you go into this particular run, it shows you that, while doing Robo testing, there were some of these bugs that were found out, right? So one of these bugs basically says that they are using an old API for laying out on the screen. The Robo was able to discover such bugs. If you go into the screenshots tab, you basically get the screenshots of all the entire run, and you can see that the basic login run was first done, and then the Robo testing started, exploring the app on its own, and it just went through all of these different scenarios. But while doing this, and like Shavik was saying, we also do some documentation. So one type of documentation is having all the performance logs there, and then also doing coverage. The coverage basically is a way of telling the user that this is the entire span of the app that has been tested during this particular run. So if some screens are missing here or some user scenarios are missing, they can reprogram our robot and tell it that, okay, next time you need to focus on other parts of the app. On the other side, also, you can actually just also see the bare Android logs and find out if there were any crashes and things like that, right? So we try to highlight all the necessary logs that you should look at, uh, if you had to debug your app.
Right, this looks great. I'll pause here and ask the audience if they have any questions so far on the product or about exploratory testing. You can put your questions on the chat. Okay. So, Shavik, how does the future look like of this Robo?
Yeah, so when you're talking about the future of Robo, we just showed you how the Robo is handling, screens across different apps, right? Just the login screen. But I think we got a question. Okay, Vilars actually asked a question. So we'll let me just pause and answer it before we go on. So Vilars said that has all the models been built by manual testing similar apps?
So yes, I mean, so what Shavik was actually going to go ahead and talk about personas in Robo testing. So what we have done is we have built some personas. So for example, imagine that you as a user, when you're given a new app, you can you sort of know how to log into the app, you know where the menu is, and you know how to use the app. So we have created a model that sort of knows some very basic information of how to explore an app, and that has been built by manually testing lots of apps. And then on top of that, what we do is when we sort of get your app, we try to find similar apps and then retrain a different model which works specific for some of these apps. Since we showed you an example of the Lyft app, these are apps which have sort of two personas. So we'll retrain the robot for those class of apps, and then the robot will work slightly different. But if we had no knowledge and no user input, then we'll use the most basic version of our model.
Okay, we have another question from Kathy, and she's asking, how long does it take to train the Robo?
Right. So, like I said, when you have the model that we have pre-trained by using lots of apps, we have already pre-trained it. So that doesn't take any time as far as the user is concerned. They can just log into our system, upload the app, and say, run a Robo test, and we'll do this very basic exploratory testing. If we had some specific examples where we had to either program in scenarios or something like that, then we will basically spend some time doing it. And the time for training is almost as equal to the time it's required for creating the test cases. If you sort of saw the demo of our test authoring tool, creating a test takes 5 minutes. So if you create around 20 to 25 tests, that's good enough data for training the robot towards that particular persona. So it takes somewhere around a day or two to train this model, but it has to be trained only once.
We also got another question from Bill, and he's asking, do you see a future when we combine script automation and exploratory automation for mobile testing? So I'd like to, actually, we just showed one way of using a scriptless recording. So in our tool, what we showed was you could record as flow, right? But I think this is very valid that Bill is asking that, hey, can there be a case where you actually can provide a script? Because, as developers, there would be custom flows, right? That would not be possible, to record. So can we, do scripting? And one feature that we have considered is, so let's go back. So when we were showing you the recording, there is actually a place where you could go in and add a script. So what you would do is while you're recording, you can actually tie in scripts there and actually tell the robot to run that script before it runs the test case. Pushkar, do you want to add something?
Right. On top of that, we are also working on scripts where, so like test scripts, or taking test scripts and trying to infer test flows from these kinds of models. Having said that, those things are very hard. I think while explaining how data is gathered for training, I basically said that you need some kind of recording tools to gather this data. And one reason for doing that is there is a limitation of what test scripts give you. Test scripts basically can give you a flow, but they don't give you additional information outside the flow. For example, they don't tell you about the state of the app when the test was being created. While in our test authoring tool, we record not simply the test itself, but also other information on what was the state of the app. For example, the entire screenshot, the entire DOM, and everything else along with it. So all that information is used to train the robot. So there is some limitation in using scripts, but I do foresee a place where we do sort of do both, except that I don't think that the scripts are going to be UI automator or XCUI tests. We will probably create our sort of own way of doing scripting for tests, and that will probably be the way to go ahead.
Yeah, and at this point, I'll just quickly go back to our tests. And if you go into a test, what you would see is that you could actually add a script block here, where you could just write your script. So this is what I was talking about before. But we want to develop this even more.
Right, and there's a feature here where you can actually also see the code here for the test that was recorded. So Bill was basically talking about an inverse where you can convert this code into similar data.
Yeah, that's actually,
and there's some limitation there, but we can. But as I said, if we have a high-level scripting language which actually gathers much more information than the test itself, it's probably possible.
Cool. Thanks for the questions, guys. If there's nothing more, I'll go back to the presentation. So before we switched, Vaibhav asked me about the future of robot testing. And so as Pushkar showed you guys that we could actually cluster login screens and say that, okay, these screens are similar. Can we actually cluster flows and use it to generate common tests across the same categories of app, right? So that's one of the things that we are actively working on, where we are trying to generate these generic tests which would apply to all the apps in the same verticals. Another thing that we are looking at and constantly seeing is that, when product managers are designing these mobile apps, they have user personas in mind, where these are different groups of people who would use the apps in certain ways. So can we model the different personas and feed it to the robot so that our bots can then model these personas and mimic them in the tests. And finally, once Robo finds a bug, then there's an issue of triaging the bug, where you have to then automatically classify, whether it's a bug or not a bug, or the severity of it, and then assign it to a person who's going to fix the bug, right? So these are the three things where I see the Robo advancing.
So Shavik, the most interesting thing, as our audience also pointed out, persona-based tests, right? So can you talk more about it? How does it work?
Yeah, so let's take an example. So let's take an example of a ride-sharing app. We all have used Lyft and Uber, but essentially these apps have two modes, a driver mode and a rider mode. So inside the rider mode, you could have different personas of riders. For example, an economy rider that could be a student, executive rider, taking rides for business, family rider, for example, a soccer mom taking kids to practice, and a party rider, right? So when the Robo is emulating these users, it has to consider the different behaviors of these users. For example, an economy rider could be age 22, always prefers a shared ride instead of a Uber premium or a full ride, uses prepaid card, and often is going to a certain destination, right? So when given a choice, this Robo will always choose something which is closer to this persona. And let's take another example, a party rider, right? Probably these are like older people than the economy rider, and always prefer premium rides, and they are going to a certain kind of destination, right? So this is how we see robo testing different personas.
Okay. So coming back to the MoQuality solution, we've showed how the test authoring tool works, how the robot training works, how the results look like. Can you talk more about how the end-to-end solution works? How do we offer it to the customers? It will be helpful for our audience.
Yeah, so there are a lot of people working on robo or crawlers, but MoQuality is the first to offer it as a product and a service, and this is how our customers have been using it today. So for the first piece, which is easy test creation, you can train the robo and just leave it on your app and let it automatically explores. Then the second piece is where you can tie it in with your CI/CD workflow, where every new version of the app is automatically being tested and the results are being reported in the cloud. And finally, all the issues that it finds, it presents visual test reports, such as screenshots, videos, you get app performance insight, errors, and UI issues, right? So this is the end-to-end solution that we offer to our clients.
And from the clients that we have, like what kind of benefits have they realized from the MoQuality solution so far?
Yeah, so the most important benefits are getting more coverage outside the testing that they had today, and finding more issues, because we also test for edge cases, which currently their tests are missing, right? So those being the primary benefits, they also get other benefits like running automated UI checks on every screen that the robo sees, getting automated test documentation like screenshots and videos, and doing all of this in an agile, continuous fashion. As their development teams are shipping apps or releasing apps, these tests are working in parallel and helping them achieve this continuous testing.
So Shavik, we have a question from Bill. He's asking, you have Android and iOS both?
Yes, yes. So our robo works on both on Android and iOS. That is right.
Okay. Do we have more questions here? So thanks a lot, Shavik and Pushkar, for sharing your insights and showing our demo of the MoQuality solution here. Let me just quickly summarize what we have talked so far and what we learned today. So we talked about exploratory testing, that it's a way to test beyond some of the predefined scenarios. And today it's being done in three different ways. One of them being freestyle, where the QA teams are free to use the app the way they wish and find errors on the go. And the other is about scenarios where they know, let's say it's a login example, and they're able to explore the app around the login scenario. And it's also about goal-based, where the goal could be, for example, increasing the coverage. So they are trying to explore as many screens in the app as they can. With the Robo, we saw how the Robo is able to present different results, capturing all the screenshots and videos and logs on the way. And Pushkar taught us about how the Robo is trained today in two different ways. One being the supervised learning, where it's learning from user inputs, and the other being unsupervised learning, which is learning from the app data. And we saw examples of the Robo working on games and the Robo working on some of the business apps. So with this, we'll conclude the webinar, and we'd like to invite you to sign up for the MoQuality Robo. You can go on app.moquality.com and sign up and put your app there, see some of the benefits. As it's a no coding solution, anybody can put their APKs or IPA files there, and it's really fast to automate these test cases. You'll immediately see some results. We are happy to provide a one-to-one demo and help you get onboarded.
Having said this, we'll also stick around for any follow-up questions that you guys might have.
So we already have one question, when is the next webinar? So the next webinar might be, in a month or so, but we are going on a roadshow over the next month in 4 cities, in Austin, Denver, Chicago, and Anaheim in California. So if you're around any of these places, then you can come and talk to us in person.
Right.
We have another question from Bill. Bill is asking, does the robot do any sort of OCR, that is comparing screens from previous versions to detect a change and maybe a bug?
So yes, we do have that. We actually put that under a bucket called accessibility testing. So what we do is, from a point of view of accessibility testing, we sort of see if all the fonts or widgets are of a good enough size or not for users to interact with, like they're not too small or things like that. And we also have a feature where if we do a run and then you upload a new version of an app, we do regression testing. So you compare the previous run to the next run. That's where you will sort of see the changes across each and every screen. Therein we highlight, if things have really changed, like a button has disappeared or things like that. And then bugs, we always find bugs. In fact, when I showed you stuff, I basically showed you our error logs. So we also show how many times those errors occurred and if they disappeared or not. We are building up a database of all of these bugs, and we classify them as low priority, medium priority, and high priority. So along with just finding bugs, you also, get triaging a little bit of that too.
Bill has also made a comment that thanks folks, that he would like to schedule the Ministry of Testing meetup. So for those folks who don't know Ministry of Testing, it's a group, and we are very actively involved with the Ministry of Testing group in Atlanta. So if you just look it up on meetup.com, that's a great place to show up, to meet with other testers and to see how people are automating their apps and websites as well.
Right.
Cool. Awesome. Thanks, guys. Thanks for attending. We'll be sticking around. So if you have any other questions, please throw it in the chat. But yeah, thanks for attending. We'll be sending out this video afterwards to all of you guys. Cool. Have a great afternoon. Bye-bye.